Hi, my name is Simon and this is a video presentation of my ENCMP 100 coding contest entry. My program is a bending moment diagram generator. This type of diagram is used extensively in civil engineering, permitting the evaluation of loads on a structural element. Specifically, the program I wrote creates a template for a bending moment diagram. The generated diagram includes support reactions, point loads, and couple moments. I was inspired to embark on this project by a course I took in my first semester of engineering. This class focused a lot on bending moment diagrams, and they weren't always easy for me to draw correctly. In fact, I would often find myself using online bending moment diagram generators, but this didn't really do much to help my comprehension of how they work. However, this coding contest allowed me to further my understanding of both bending moment diagrams and programming with the Python language. That covers why I made this program, but what is even more important is how I made it. Admittedly, I wrote this entire program in the span of 2 days, and produced this video at 1 in the morning. Despite this, I believe that the process of iterative testing and improvement was not lost. During the 12 hours I spent writing the code for this bending moment diagram generator, I was continuously learning from my mistakes, both big and small. Now, onto the functionality of the program. First, a user is greeted with a welcome message, explaining the purpose of the program and offering details regarding sign convention and units. Next, the user is prompted to input the length of the beam, the number of supports, the types of supports, either pinned, rollered, or fixed, as well as the location of the support along the beam. Now, the program is able to complete the first phase of the bending moment diagram and displays a figure to the user, confirming that they want to continue. Subsequently, the user is asked the total number of point forces acting on a beam, their locations, their magnitudes, and their angles. This allows the drawing of detailed arrows and labels to identify each point force. Once again, the user is shown an updated figure and asked to verify that all information appears correct. The final phase of the program prompts the user to enter the total number of couple moments acting on the beam, along with their magnitudes and directions. With this information, the program draws accurate circles with arrows corresponding to the correct sign convention. At this point, all data input is completed. The program asks the user once more to confirm the validity of entered data. Then, the user is given the option to save an image file of the bending moment diagram to their local disk. Unfortunately, since I created this program in such a short time, I do not have earlier versions for comparison. However, the structure of the program itself represents how it was developed. The 3 checkpoints throughout the program allowed me to monitor its behavior and troubleshoot bugs as they appeared. With this process, I was able to quickly identify issues and errors and correct them before they caused additional consequences. A key aspect of this program is the modularity of its code. It was designed such that certain actions could be easily invoked through the use of functions. A major benefit of this is a program that is easier to follow and better organized. Another important feature of my program is its efficient and well-considered user interface. It was coded to prevent simple disturbances such as white space and negative signs from causing runtime errors. Overall, I believe that my coding contest entry is original because of its utilization of the matplotlib library to carefully arrange shapes and lines to represent a beam, numerous forces, as well as support reactions and couple moments. Now, I realize that my program is not a true bending moment diagram generator, as it does not display the graphs of shear force and bending moment. I realized midway through the development process that I did not have the time nor the skills to program this functionality. Nonetheless, this served as an important lesson, teaching me that some ideas are simply unattainable due to constraints or lack of expertise. I am grateful to have had this learning experience, which sharpened my Python programming and troubleshooting skills. As well, I was able to deepen my understanding of an engineering topic that I once found quite difficult. Thank you.